if you look on your unit circle, you can bring it back into the first positive revolution, where you normally start at 0. If you go counterclockwise, you end up at 2 pi. Now, what we're dealing with here is where we have the 4 on the bottom. So the equivalent for 2 pi, you have 2 pi, you put it over 1, then you multiply the bottom and the top by 4. The 4 multiplies with the 2, so 2 pi is basically the same thing as 8 pi over 4. And you can always check, because 8 divided by 4 would turn into a 2, and you'd have 2 pi. So you can always check that you did it right that way. So in other words, 2 pi is the same thing as 8 pi over 4. So what we're trying to do is we're trying to bring the angle back within the first standard positive revolution. That way we'll be able to find the answer very quickly. So if you see it's a negative number, the easiest way to think about it is that you're just adding 2 pi to it until it's within the first revolution. It has to be some number between 0 and 8 pi over 4, some angle. And we saw just now that 8 pi is the same thing. 8 pi over 4 is the same thing as 2 pi. So instead of saying 2 pi, or actually I'll show the work here, just in the process, what you're doing is you're just adding 2 pi to it. And we found out that that's the same thing as 8 pi over 4. This gives you negative 1 pi over 4, which you can just say is negative pi over 4. You just do it again. You just add another 2 pi to it, which we saw is the same thing as saying add 8 pi over 4 to it. So this is the same thing as 8 minus the 1 here. There's an understood 1. 8 pi minus 1 pi is the same thing as positive 7 pi over 4. So in the first positive revolution, what we're looking for is this angle. And that angle happens to be right over here. This is where 7 pi over 4 is. So now that we have that, we have to know what its coordinates are. And specifically, in fact, even before that, let's see which coordinate do we really need, because we don't need all of them. If it's just asking for secant, we just need the cosine coordinate. There are 3 standard coordinates that you want to have memorized. But in reality, if you want to go further, there's 6. Like you have the cosine here, then you have sine, tangent, but then you have the reciprocals. So if you knew the secant one right away, you would get the answer immediately. You can have secant, this would be cosecant, this would be cotangent. Having the top 3 is enough. So let me show you that method. We only need cosine because that goes with secant. Once we get the cosine, all we have to do is flip it over. This is the relationship between the two. So once we get the cosine, we'll flip it over and we'll get secant. And then here specifically the cosine, that's the positive square root of 2 over 2. So we don't need the other 2. We don't need sine and tangent. We just needed this. But specifically, this is the cosine. This isn't the final answer, but it's right in front of the final answer. So what you do is you just use this concept here. You just flip it over. Just put the 2 on top and the square root of 2 on the bottom. If you have a radical on the bottom, you can't stop there. You multiply by the top. You multiply the top and the bottom by the radical. This turns into 2 times the square root of 2. On the bottom, if you have the same exact thing under the radical, you just write that one number one time without the radical. Here's what's really happening. You have the 2 radicals. They have the same index, so it's like saying 2 times 2. And then maybe I'll write that out on the side here. It's the same thing as saying 2 times 2 on the bottom. And then that's the same thing as saying either you can say 2 squared or you can say 4. But the same thing happens. Here, this simplifies to 2, and the square root of 4 is 2. And here, you're just going to take the positive root. So you put a 2 on the bottom. The 2's cancel each other out. All that's left is the square root of 2, and that's the final answer.